my screen is being shared or not?
Yes, sir. You have to share. You will be finding a link for screening, share screening. Share screen. You're not getting a link. I think this is there in.
Ashok sir, we are live now.
Okay, so fine. Uh, that's fine. That's fine. Very nice. So it's my privilege to welcome our speaker, a very renowned speaker, a very dynamic researcher in the area of speech recognition, Dr. Karan Natwaniji. Presently, he is working as an assistant professor in School of Electrical Computing in IIT Jammu. He has done his PhD from IIT Kanpur and MTech from Atal Bihari Vajpayee Institute of Information and Technology Management from Gwalior. And in addition to it, he has done postdoc twice from France, IRNIS and one other institution, very reputed institution from where he was a postdoctoral fellow for in two different locations. Uh, he's having presently he's having so many projects in his account, and he's having one project from the SERB and CRG as well, that is under the CRG Council of title Intelligently Improvement of Speech in Realistic Noisy Environment. He's also having, he has all, I think he's about to complete one more project from DRDO in underwater communications, one more project in fast computation of principal components for self-noise cancellation in underwater acoustic has been approved. And also have heard that one more project from TIH, Technology Incubation Hub from IIT Kharagpur, I suppose. He has got one more project
IT Patna.
in his account. Presently, he's by IIT Patna. Yes, sir. So,
Yeah.
so presently, he's guiding 4 scholars in the area of speech recognitions, and his publications is in very reputed SCI journals. It's really wonderful. It's really wonderful to have such a vast researcher and as well as academicians on board for this FDP. And it's really very proud moment for us to have such a personality. And it's all because of the COVID. We can catch the personality like Dr. Karan Natwani. Otherwise, they are very busy in all the projects and the consultancy they are undergoing in IITs or some other reputed institutions. But thanks that we got a chance to, because of the COVID, we got a chance to have a virtual meeting. Thank you very much, sir, for kind acceptance. And I welcome you once again on behalf of Badaba Campus, University of Jammu, and Teaching Learning Center of Ramajan College of Delhi University in this FTP. Thank you very much, sir, for accepting our request to be a speaker on this occasion. Now, over to you, sir. Please continue. I will be sharing the link soon on your WhatsApp. Please, sir, go ahead.
Okay. Thank you very much for this wonderful introduction about my credentials. So currently, I'm actually working in actually a wide domain of areas, which I just want to brief you about that. And also, it's a welcome for anyone who wants to do internship or wants to take forward their research in one of my areas. So it is welcome for everyone. So currently, I'm dealing in too many things. Like one is like in speech recognition, as suggested by Dr. Ashok. And in addition to that, I'm also working in underwater acoustics. So this is one of the defense application. So it actually requires like some of the classified information needs to be localized. For example, if I need to detect the enemy submarine, so I'm working in that area, like localization of the submarines and also the noise cancellation in underwater acoustics. So these are like few areas which I have started working in Jammu. And before coming to IIT Jammu, I was working in speech intelligibility, on which I have one project. So that was one of the major areas. And in my PhD, I worked on speech quality, speech enhancement, and speech recognition as well. So these are like wide domain of areas. And recently, I started working on baby cry classification. Actually, this is also very useful topic, like what actually the cries of baby correspond. So there are a few classification problem comes in, like if it is the babies are crying because of what reasons. So I need to identify that reason for the classification here. So coming to the topic of today's of interest to one and all. So it's one of the important topic in speech recognition. So the idea is like speech recognition is like how we actually transform the speech to text. So this is one of the important thing that the microphones which captures the our speech. If in case, like it is quite possible that if in case they are being shifted, the microphone has been dislocated. Dislocated means their position, initial position has been shifted to another position, and that may be because of many reasons. For example, human interventions, maybe because of regular maintenance, and actually the microphones mounted on a particular panel, it has been shifted during the maintenance or during any interventions. So this is one of the important point that we want to analyze. What is an impact of this movement or this dislocation of the microphone position, and what is an impact on the multi-channel distant speech recognition, and also on the intelligibility of the sound. Once the sound is not intelligible, or once the sound is not at all recognized, the everything is lost. So this is one of the important topic which I'm going to take it forward. And please stop me in between if you have any queries, and make it more interactive if you want. So this is like rather than talking me only, and I want you to also interact in between. So you are free to do that. So let's start talk about the background first. So here you can see the multi-channel distant speech recognition carries multiple microphones. The multi-channel means there are multiple microphones placed or mounted on a panel, and we have a multiple speakers. So this is a very general case. You can take it one speaker at the moment. You can take multiple speakers. So I'm just taking n speakers, m microphones. So you can see that when you place a microphone in a room position, so the sound travel to the microphone is not a direct one. There is multiple ways the sound can reaches to the microphone. One way is the direct, as you can see, this is the direct path. One way is like via surrounding, reflecting from the surrounding walls or some obstacles present in the room, and that will be captured by the microphone. So let's say the speaker utterances spoken by the multiple speakers are U1, U2, and UNT. Means there are n speakers, they are speaking continuously. And microphone output is being captured after doing the multiple reflections, after capturing the room impulse response, the characterizing the room impulse response. The microphone output, which corresponds to O1T, O2T, and OMT, where actually M corresponds to your number of microphones. So this is a general scenario. This is general scenario means it fit to any kind of environment. When you talk about in the room acoustics, let's see what are the two steps which we will be using to analyze the multi-channel distant speech recognition. Once we have the multiple microphone captured by the multi-microphone capturing the data. So we have O1 to OM. There are multi-channels. So in order to analyze them, we first do the beamformer. The beamformer is a very useful array signal processing technique, which does the conversion of multi-channel information into a single channel. So what they do, one of the simplest method is the delay sum beamformer. The delay captured by these microphones, like first, if this is a reference microphones, so I will first compute the delay between these two, then between one and third, between one and fourth, like this, one and last. So I will first capture the delay, and then I will compensate the delay between them, and then average them, and then we will get a single output, which is known as delay sum beamformer output. So this is one of the simplest I'm talking about, in the sense that for layman people, it is something like this. This is an averaging. First, compensate the delays between the microphones, and then average them. There are many other ways to do that. Like one way is MVDR, minimum variance distortion and response. This is has an added advantage over delay sum beamformer, because it actually beam in a particular direction of the target. And the MVDR are quite wide useful in the localization of the sources. Like for example, I'm present at XYZ location, another person is at X1, Y1, and Z1 location. So MVDR will wants to target in a particular direction. It will make full gain in that direction and put nulls, or you can say the gain is very less in other direction. So those are the other added advantage with MVDR beamformers. So this is the knowledge we can get from the beamformer. Now, next step is the speech recognition. Speech recognition does the text speech to text conversion. Now, whatever the spoken sentences after combining into a single channel, you want to transform into a transcript. Transcript means they are having the either in the words which can be combined together to form a sentences. So there are many ways to do that. The backend engine. The backend engine means the speech recognition engine nowadays has multiple ways to do that. We have inbuilt Google engine. We have inbuilt deep speech, that is of Facebook engine. So multiple engines are available which are open source. Anyone can use them for any application. So once you can get in the words form, or you can get the transcript in the character form. So there's a two ways to get the transcription. One is the words from the waves, that is the audio to words, and audio to characters. So these are the ways we can actually transform the wave into the transcriptions. Now, let's see what are the problems assumed that microphone location are known. So this is very generic problem. People are working on this problem. They have actually forget about one of the realistic scenarios where the paradigm has shifted now, that when the microphone location is being shifted from their original one, the speech recognition performance degrades significantly. And in addition to that, multiple other objective evaluations like in the intelligibility and the quality of the sound are also detrimental to that effect. So this is the problem. But first I will tell you what have been done till now. So people have assumed the microphone locations are known beforehand. So intelligibility of sound we want to compute, and we have to compute the performance of speech recognition by using the beamformed output, or that is bold OT, which we pass to a general purpose. General purpose I'm talking about. I'm not going into more details about the speech recognitions, that what exact you can do that. But I just want to give you in a more realistic scenario, what are the people doing in the current domain? What are the industries are working on? They are using the general purpose ASR. They do not want to train the models now. It is quite complex. What they're trying to locate is the before passing the signal to the this general purpose ASR, they are trying to modify the sounds. This is one other area which people have started working in this direction. And finally, we get the transcription out of the ASR. So as I already told in my beginning of the slides, that when you have a room, there is an associated impulse response. What do you mean by that? Like, as I said, the sound travel from a speaker to a microphone will reach multiple ways. One is a direct path. That is, the sound comes directly to the microphone. One is while reflecting the only one wave, one wall, it reflected and come. And the third one is like multiple reflections from the surrounding walls. So in that case, you have late reflections. So the first one is the direct path. As you can see, the direct path has more energy, as it is quite obvious because it is coming directly. The intensity of the sound is much higher. Second one is early reflections, means the only one of the walls has been the sound is been reflected and comes to the microphone. And now you have a late reflections. Late reflection means the sound is being reflected and attenuated, means the energy reduces after each reflection, and there are multiple reflections. So sound intensity goes down. That is why you can see the energy of room impulse response is less there. And these are very, very detrimental to the speech intelligibility and quality. So spending some more time on the room impulse response, I just want to give you an insight of that. What is an impact of early reflections and what is an impact of late reflections? So early reflections are very detrimental to the coloration of effect, means the phonemes. Like when we speak, we transfer the basic sound unit is phonemes. So phonemes have energy. So there is a sparing in the energy, means you find a spaciousness in the sound. Like if I say hello, the sound will become hello, like this. So spaciousness comes into the picture when you talk about the early reflections. Now, the second is your late reflections. The late reflections has an overlap masking effect, which actually on the low frequency envelopes. So it detroits the low frequency envelope. So this late reflections causes the envelope to be degraded of the low frequency regions. So this is the overall impact of the late reflections and the early reflection. Now coming back to the how impulse response is being characterized. So you can see the impulse response is characterized by a number of parameters. First one is C, which is speed of sound. Then second one is Fs, which is your sampling frequency. Third one is R, which is your microphone location. Where is your the location of the microphone situated? Then S, which corresponds to your source location. And then L, that is your room dimension, in which room you are sitting. So what is the dimension? X, you need to give the three-dimensional information. Beta is your reverberation parameter. It means that what is the RT60 value? RT60 tells you the energy of the reverberation. So if RT60 is very high, the reverberation content is too much. So like, for example, if I say high, so it will be high. This is less reverberated. If it is more reverberated and it's high like this. So there is a more spaciousness, means reverberation parameter is higher in that case. So all these parameters are very, very sensitive from their known values. However, the question is, which one of them, which among them is the most sensitive? So the most sensitive is your microphone location. If there is a change in the microphone position, this is a significant distortion in the your intelligibility, in quality, and as well as in recognition performance. So we will take care of this R factor and detail it more in coming slides. Yeah. So here is our few experimental results which we have placed and what we have proposed and also accepted in good conferences and journal. So here, let's say if there is a change in the microphone position, let's say initially it is R, it is moves to R epsilon by slight change it. Then what is an impact on the room impulse response? Because your speech recognition is completely dependent upon the room impulse response. And people have done a lot of work on that, but none of them have tried to see the impact of the change in the microphone location. So this is an advantage of this work, that you can actually take this and then try to locate how much performance distortion or how much performance deviation is coming. So once there is a change in the microphone position, there is a change in the room impulse response. Now, the question comes, what is the relation between the two? Means, how can I say if RE means R epsilon is following some distribution? So what is the distribution followed by our room impulse response? H epsilon. So this is where we will be focusing our work. And let's take one example here. This is our microphone location in the three-dimensional view. That is, we have a XYZ location and we have a one source placed here. Now you can see, if this is the original, in the middle was an original, and after dislocation, it has been shifted in the radius of some, let's say, epsilon radius, it has been shifted. That is what epsilon corresponds here. Now, actual position, if it is an actual, this is my room impulse response, means it has a direct path, then it has a late early reflections, then it has a late reflections. Now, if the microphone has been shifted by some reason, as I told, the reasons are human interventions, the routine maintenance. How the displaced location, the RIR, is being shown like this. So you can see there is a significant difference in the early parts and also the late part. Now, this is an error I computed between the two, and this error is going to help us in many ways. I can find the error follow some distribution. So I will try to locate that. I will try to find out some important analysis on that whether this error between the error RIR estimation follow some distribution. So we will take some analysis on top of it. Coming on to the same question, the relation between R epsilon, that is your microphone location position error, and room impulse response error H epsilon. To do this, what we will be doing is, we say that the R in input let's say we have some initial position XR, YR, ZR, and some the parameters which are fixed, which are not going to be have sensitive, which are less sensitive to the change. So I will place them first, input. Then I generate the room impulse response using one of the oldest method and one of the versatile method, that is known as image method. They have tried to find the image content and try to get the room impulse response between the two locations. Now, I also took this, what is this? I say the sigma square, that is the variance. If I say that my the change, this error follows a Gaussian distribution. If I say that this microphone position error follows the Gaussian distribution, so I will start with a zero mean and a variance sigma square. But I can vary the sigma square, and then I can plot different measurement error distribution. One is with 0.1, G is equal to 0, which means 0, and 0.5. Here G is equal to 0 and 1. So you can see with the change in the variance, the error also changes. The distribution of the error also change. And this is quite obvious too. Now, I wanted to find a relation, as I said, between this position error and what is an error comes in the room impulse response. So when I generate this error by using different sigma values, I then add them to form my microphone position error. Then I generate the room impulse response with the original position and the shifted position. That is your microphone dislocated position, H and H epsilon. Then I find the Euclidean distance. D1 corresponds to your Euclidean distance between H and H epsilon. And then cosine. This is the another matrix which we have used to find the distance between the original H, which is my original position, the actual one, and my dislocated position, H epsilon. Then these are the values. You know, Euclidean is nothing but mean square error, and cosine is your nothing but the angle between the X and between H and H epsilon. So this is what you will be getting in return. Then I wanted to plot these Ds, D1 and D2, and then see is their distribution also a Gaussian or not. So then I can be very sure the error, it follows, the position error follows a Gaussian distribution, whether my H epsilon, that is your RIR error, follows some distribution or not. So let's do that. And interestingly, we saw that when we do the Euclidean distance, we plot for three different Gaussian error, G 0.1, G 0.5, G 0 and 1. We plot the corresponding the room impulse response error, that is your Euclidean distance, and interestingly, all of them follows a Gaussian distribution, but we do not have a zero mean there. They had been shifted. It is not zero mean, but there is a Gaussian distribution. That is a one important aspect. This is one important relation which we have analyzed, which we have produced, and we have presented this work in Interspeech, one of the good conference and one a tier 1 conference, flagship conference in signal processing. Then I also plotted this cosine distance, and then again the idea was the same, that we got a distribution which is somewhat similar to Gaussian, but it has been shifted. That is, the mean is not 0. It has been shifted to 0.98. This is shifted to 0.99. This is shifted to 1. So it gives a clear indication that there is a relation. Definitely there is a relation. If I say my microphone position error follows a Gaussian distribution, then the error in the room impulse response is also a Gaussian, but with a different mean and variance. With this analysis, we want to analyze what is the impact of this change in the microphone onto the quality as well as on the intelligibility. So we took two measures for quality. One is speech distortion ratio, the signal distortion ratio in dB, and NPM. We took this normalized power measure, which is also computed herein. So these are the two methods which we use for the speech quality. And for intelligibility, one of the flagship method, or you can say in literature it has gone like very beautifully, is like short time objective intelligibility. This is one of the measure which gives the values between 0 to 1. Higher towards 1, the better is the intelligibility of the sound. So we want to see the impact of RIR on both the things, quality as well as the intelligibility. Let's pay more attention on finding out the variations of speed distortion ratio with the position error. So we have plotted the mean, the upper bound and lower bound, and it is quite phenomenal. As you change the distance, you change the microphone location, error increases. Means if you increase the error, obviously the performance goes down. That is, there is a significant drop in SDR values when you increase the position error. And similarly, NPM is also has similar impact, as you can see here, with the distance from the actual microphone position. So what an important observation, or you can say the key observation, even with a small 3 centimeter displacement, even a 3 centimeter displacement, there is a significant loss of 10 dB in SDR. Means the quality goes down by 10 dB. So such a like bad impact on the quality has really need to be checked while we take into the account the displacement error and how much onto the speech recognition we will be placing one important aspect now. Now coming on to the STOI variations with respect to the position error, we can see that the significant drop in the STOI when we change the distance from the actual position, and when we increase the distance, the intelligibility goes down significantly. So this is again a very important observation we took while observing the impact of the change in the position error on the quality as well as the intelligibility. Now coming on to our impact on the recognition, so we may have to define a problem first. The problem is we have a microphone signal, which we have already told in the beginning of my slide. It is formed by the convolution of room impulse response with the signal plus noise there. So this H is in my room impulse response. So this, as I said, it depends upon few parameters. I have just repeated it again. My speed of sound, sampling frequency, microphone location, speaker location, the other parameters like room parameters, the reverberation parameter, and also the number of samples which we want to develop. So this is a very important point, that H has an impact on all of the parameters, but most sensitive is your microphone location, which we have already seen that. Now, if there's a change in the microphone location, it's changed from X to X epsilon, Y to Y epsilon, Z to Z epsilon, when where M corresponds to your number of microphones. Now, in the last scenario, we took only one microphone, but now we will do the multi-channel information. So M corresponds to 1 to capital M, where M goes from 0, or you can say 1 to, let's say 10 sensors you have placed, or 10 microphones you have placed. Similarly, H is being leads to H epsilon, and which with the same rule, and how the signal OT has been transformed to O epsilon. Now our objective is to find the impact on recognition on this O epsilon, which is your received signal, or you can say the observed signal after the dislocation. Now the problem is to see the influence, to see, or you can say the investigate the influence of the dislocation of set of microphones in a closed room on recognition performance and intelligibility performance. As I said, we have M microphones in multi-channel scenario and N speakers in a particular room. So how well this general purpose ASR engine changes, or you can say the impact on the general purpose ASR when the microphone has been shifted. So we show that the even a 1 centimeter error, which we have showed that 3 centimeter gives you 10 dB degradation in your speech quality performance. We will show in speech recognition that 1 centimeter error in the microphone location is equivalent to 10 dB of additive noise. That is what we have also seen in the previous case in terms of ASR performance. So this is a very, very important point, which we will be showing and we will be demonstrating today. So as I said, this is a multi-microphone scenario, that is a multi-channel. So O1 to OM is given by the convolution of H11 with U1T, H21 with U2T plus HN1 to UNT. This is a matrix representation. And similarly, OMT is like HM1 to U1T to HM2 convolved with U2T and HNM convolved to UNT. And then you add them to get the information for the mth microphone. Now, in short, let's say speech recorded at the lth, let's say one of the microphone is given by HIL convolved with UIL, which is pretty easy. And then we sum it for all the number of samples. Now, what is an error in a measurement? Error in a measurement is change only comes in the room impulse response. As I already proven here, the room impulse response, if changes, your change in your signal. So we say the same thing here. So error in measurement, change in the error in the output speech. So HIL epsilon UIT with convolution. Now, our multi-channel distant speech recognition involves two steps. One, we do the beamforming on the M microphone output, followed by the general purpose ASR. The general purpose ASR, as I already said, we use the speech engines, available speech engines, what we have speech recognition engine, which we use end-to-end wave to vector, the transformer, which we have used in our case. So this is the problem here. We first compute the T when there is no error. T is your general purpose ASR. And then again, we compute T epsilon when there is an error in the microphone locations. Means the output of the speech is also being distorted. So O1 epsilon to OM, we take the beamformer and then we pass it to general purpose ASR. So we will observe the error in the in each of the output of the microphone, and also the error in the intelligibility, and also resulting the error in the speech recognition, which we are going to analyze and present some results in short while. So let's see how the experimental setup goes. So experimental setup is having, let's say, 4 microphone and 2 speaker in a room location of 5 cross 5 cross 5, where M1 is placed at 1 to 5 centimeter. M2 is 5 centimeter, 4 centimeter, 4 centimeter. M3 and M4 is also mentioned here. Speaker 1 and speaker 2 is at 2 to 3 centimeter, 3 to 3 centimeters. So, and how the signal is being generated, we took the Libre speech, which is an open source database. From there, we took 2 speakers, and that has been randomly chosen from the multiple sequences there. So first speaker will speak, then second speaker. So speaker 2 and speaker 1. So one speaker is second speaker this, and then we combine the 2 information. For now, you may also ask that we have not taken the overlapping in the speech, because our objective was not the same. That we are not here to do the source separation. We wanted to see the impact on the ASR. So that it would be having a different problem if I have taken an overlap on the speaker. For example, speaker 1 and speaker 2 are speaking at the same time. So then your problem is completely different in that scenario. Okay. So we randomly select 2 audio files, U1 and U2 from Libre speech, as I already told, and then using this way, using this particular way, we obtain O1, we obtain our clean speech signal UT, which is U1 speaker from 1 to T1 second, U2 from T1 to T2. Then like this, we alternatively, we have asked them to combine them. So this is just like I'm speaking, other person on other phone will speak when I will end. Then when he will end, then I will speak again. So this scenario we have taken in the current experimental setup. Now we uses the room impulse response to construct the multi-channel output, as I already told, O1, O2, O3, O4. Now in the previous case, we have taken N microphones. Now we have make it very specific, 4 microphones, 2 speakers. Now similar with the H with an error, with a different Gaussian error, as I said, the Gaussian error in room impulse response with a different variants, we generated H epsilon. With this H epsilon, we generated new outputs, which is O1 epsilon, O2 epsilon, O3, and O4. And then finally, we compared the 2 methods. Finally, we use 2 methods to found the performance. First one is speech intelligibility. So we have the beamformer output on the 4, the clean signal, O1, O2, O3, O4, and this is where the location is not been shifted. This is where the location has been shifted, so you get O epsilon there. Now, what are the different beamformer I have used in this work? So we have used 2 beamformer. One is DSB, that is delay sum beamformer. Second was MVDR, which I have already told in the beginning of this lecture. So we told that we can have 2 different set of beamformer, and then we get O and O epsilon. Now we compare the general purpose ASR to obtain the multi-channel speech recognition performance, and also general purpose ASR for the shifted microphone output. And as I said, we have used end-to-end transformer speech. This is a deep speech model which we have used. And if someone wants, we can share that code as well for their own purpose, for their research. So this is an open source also. If you want, I can share the link as well. So once we get this, we found for different position error, we saw that the DSB having the low character error rate, which have been averaged over 100 runs at four different microphone locations. Now, higher measurement error, obviously, when you increase the measurement error, the performance goes down significantly. However, the DSB has been better performance than the MVDR. So, which is one of the plausible argument in that case is the MVDR is highly susceptible to singularity in the similarity when we compute the inverse matrix, which requires in the calculation of the weight matrix. So inverse is when we do the inverse, the singularity problem comes a lot in MVDR, and that is why they are not been able to achieve a good performance as displayed by DSB. So now showing the effect of microphone position on speech recognition, that is how this is the same thing actually. This is one single mean value we have averaged. Here we have multiple, we can see the means also, outliers also, range also, median line also. We have computed all the confidence information, which we wanted to prove that the impact of variance plays a very important role on the CER. That is, if you increase the microphone position error, the CER increases. So lower the CER, better is the method, because character error rate should be lesser for a method to be known to be a good speech recognition performance. So we computed for 100 runs again for DSB. Similarly, we have computed for MVDR, and we saw that when microphone error position is very high, that is 1, there is a significant variation in the character error rate, and which is also visible from the performance. Now, I would like to know that how the impact the noise on the speech recognition. Now, up till now, we have not taken the noise into account. Now, what we will be doing, we have a clean signal U, which we have generated, as I showed, speaker 1 first speaker 2, then next, then speaker 1, then speaker 2, like this alternatively. When I add the noise in that signal, how it actually changes our speech recognition performance, that is what we want to analyze through this performance method. So again, as I said, UT, which we have already computed, we add the additive white Gaussian noise at 4 different noise level. Let's say 0 dB, 5 dB, 10 dB, 15 dB. And when we increase the SNR, the CER decreases. That is quite obvious, because CER has better performance when you have the SNR is higher. So we can see the results as well. When we take 20 dB into the account, means when we have a 20 dB SNR, the character error rate is very less, 8.7. However, when we have a 0 dB, the character error rate is around 71. So this is too high. So this is where we can say that the impact of noise on speech recognition. When you increase the SNR values, the CER goes down significantly, so that they are inversely proportional to each other. We also see that the outliers and variance in character error rates are consistently increasing, means they are actually increasing when we increase the signal strength. And that is one thing which is quite obvious from the results as well. So I'm now concluding my slide very soon, that how the impact, this is again the same thing which I wanted to emphasize again, that the impact of CER on the variance we have seen, impact of CER on the SNR we have seen. Now one can finally hypothesize that the measurement error in the microphone position is directly equivalent, or you can say directly proportional to an ambient noise of 5 to 10 dB. So we have already proven one important point, that when we change one single centimeter, there is a change in the 10 dB. The same thing we observed in the performance in the speech recognition. So they are actually going hand on hand. So speech recognition and the quality degradation with respect to the microphone location are approximately similar. So we just want to give more emphasis on the intelligibility and quality. We computed the SQI and mutual information, and SDR, PESQ, and LLR for speech quality. So we can see the few observations here. I have mentioned down it also for those who want to come directly to the key observations. So DSB holds better speech quality, while MVDR claims better speech intelligibility. One thing. While also we see that microphone position error, both the MVDR and DSB performance degraded for intelligibility as well as the quality. And for short-time objective intelligibility, the maximum degradation in DSB and MVDR is observed to 25% and 49% respectively. Now let's move on to the performance on the noise, that how the intelligibility and quality varies with the SNR. Again, we see that the as SNR increases, the intelligibility and quality scores also increases, because they have a better performance when we have a better signal quality, and better signal is there at higher SNR. So this is quite obvious. Similarly, when we see that STOI and PESQ and SDR very slowly, actually they changes very slowly when compared to MI and LLR scores. So similar to CER, the effective change is observed at 10 dB SNR. So this is, again, you can see that this is what we have already proven, that the significant change in 1 centimeter change in the, or 3 centimeter change in the microphone location is 10 dB. So this is what we have also proven here from the intelligibility and quality scores. So finally, I would like to conclude the talk here, that we had shown the impact of error in microphone location, and we have shown the performance on the multi speech recognition as well as on the intelligibility and quality. So speech intelligibility and CER scores do not change significantly when error in microphone is more than 0.5. So it indicates that the higher degree of error in microphone position does not deteriorate the performance of the general purpose ASR. And also we observed that with a change in 3 centimeter of the microphone, there is a change of 10 dB additive noise added into the signal, or you can say in the performance of CER. So this is like a few observations which we obtained, and this is one of the realistic problem which we started working, and now we are moving on to another point after this, is like finding the optimal location. If in case, let's suppose, if the microphone has been shifted to a new location, what is the right position, so that we can actually improve our recognition performance. So that is another task, and for that we are using the deep learning methods, where we would like to find those locations on the basis of which have lowest character error rate. So that position we have to find, and so we are working on that problem as a future work. Thank you very much for being patient listening. I'm open for the questions. Hello. Hello. Can you hear me?
Yes, sir. Please.
Yeah. So if you have any questions, so I'm open for the questions.
Okay, sir. Let me check this on the YouTube portal. Just give me a minute. No, sir. No queries on the YouTube.
Okay. So anyone else would like to ask? Yeah.
Hello. Good morning, sir. I am Dr. Jitendra from Bhadrava Campus, University of Jammu. I am head of the
sir, we have met before also. How are you?
Yeah. So anyways, nice presentation, sir. Nice presentation.
Thank you very much.
I want to clarify few my queries, that what technology you use for, what platform you use for analyzing these signals and all.
We generated the data in MATLAB, Then
Right.
we use the Python to develop the deep speech engine, which performs, which takes our waves and transform into the text. And then we have a Perl script which we have written to find the comparison between the original wave file and the shifted wave file, that is microphone located. So we compare the character array between the two in the in the Perl file. And then finally we plot, and in Excel sheet we have the CSV file which we generated for 100 runs. So we have the CSV which we have transformed. So from there we can plot the results and then show it.
Right.
So it's actually the multi platforms, you can say that. It's not one single platform. MATLAB is used to generate the audio signals, then go to the Python, and then like this. Yeah.
Okay. And then second thing is that your entire case study is to shift the microphone location from one place to another, right? If source is going to be shifted from, because there may be chances, like now I am talking to you, my microphone is still, but my being source, I am going to be minutely going to shift from one location to another.
Correct.
So same, I think the same impact is going to be
same impact is going to be happen, but only thing is that we have taken other problem. We have changed the microphone location. The source is stationary, but you can transform the problem. Microphone is fixed and source is moving. So that is also, but it is an interesting to see whether it has a similar impact, the performance wise or not.
Yeah.
It's a very good point, I believe. Yeah, this is a very good study we can try in future also. Yeah.
And third point is one of my scholars is also, I'm going to do some take new field. We are going to prepare the synopsis of one of my scholar, that we will capture the EEG signal and we will go for the motion detection.
Yes.
So in case like a lot of quantum physics is involved, a lot of signals are involved.
Yes.
So in future also we are going to take your help in that
case.
Because
I'm actually happy to inform you that I've started working in EEG. I have bought 2 EEG machines. So what I'm going to do is like when a person is sitting, how EEG is responding. When person is sleeping, how EEG is responding. If there is an impact on some of your body parts, like some paralysis has happened from some inpatient, so we can extract that information. So one of my PhD student is working in that area actually. Yeah.
So basically we have still not decided whether we go for the motion detection or we go for the EEG signal in healthcare. So we are in the process of that. Within 1 week, we are going to decide on what field we are going to do.
We can, if you want, we can have an offline discussion if you want. I can help you out.
In case you allow, I can come with my scholar also.
Sure. That is very good. We can have a first online meeting as well, and then you can come and meet me in person as well. Not a problem.
Right. So nice. Thank you. And you are most welcome to my campus also anytime.
Sure. I was in touch with Dr. Ashok. He's asked me that you should come once. So I said,
yeah.
When there is a snow, let me know. I'll come that time.
Okay. No. You can come in snow also.
Thank you.
Yeah. Thank you, sir. Thank you.
So that's great, sir. So
thank you, Ashokji. Yeah.
Thank you very much, sir, for your accepting our request. And this talk was really a wonderful, and really we will look forward for further collaboration, as my head, Dr. Natwaniji said. And we will shortly trying our very best, if COVID permits, to board you on our campus for more interaction with our scholars. So that we can start something fruitful for the same.
Definitely. Thank you very much. Yeah.
So once again, I thank you. I extend my thanks to you on behalf of the Department of Computer Science, University of Jammu, Vadava campus and Teaching Learning Center, sir. Definitely, it's great. It's our pleasure, and we have to learn a lot from your experiences, and your area of research is really very emerging one. We will definitely keep in touch and going for some future collaboration for the same as well, sir. Thank you. Thanks a lot, sir. Dr.
Thank you for giving me this opportunity. Thank you to interact with you all. Thank you very much. Yeah.
Thank you.
Thank you. So should I leave?
Dr. Arun, would you like to add something? Okay.
Yes, sir. Hello.
Yeah. Hello. Yeah.
Yes.
Yes. Thank you, Dr. Karan. It was really a very nice, informative session. In fact, I would like to add one more thing. My guide is working in the same area, that is speech recognition, Professor Amita Dev. Yes, she is currently the Vice Chancellor of IGTTUW, Delhi. So
Well,
she occasionally called me that, Arun, can you please suggest me something in this speech recognition area? I say, no, ma'am, this is not my area. My area is a sensor network and all. So now if something comes to me, so I can directly forward that query
sure,
to
sure.
you, sir.
Sure, sir. Sure. I would be happy
So,
to
sir,
collaborate. Yeah.
oh, sir, thanks a lot, sir. Thanks a lot for this session also.
Thank you, sir. Thank you.
Thank you. Thank you.
Okay.
Ashok, sir.
Hello. Hello.
Fine, sir. Fine.
Yeah,
Thank
fine.
you.
Okay. Thank you. Thank you very much.
Thank you, sir. So we will keep in touch, sir. Thank
Sure,
you.
sure. Thank you. Bye-bye. Bye-bye, everyone.
Bye, sir.
Bye.
So very good morning, Prajapati, sir.
Yes, very good morning.
So we
Am I
will be
audible?
beginning in just, yeah. I'm fine, sir. I'm fine.
I am actually connecting my iPad so that I can share my content too. So give 1-2 minutes.
Sure, sir. Sure. Ashok sir, can you please introduce our keynote speaker?
Yes, am I audible? Sir?
Yes, sir, you are audible.
Okay. So, dear friends, today I would like to share some experience that I have been using in information security domain, certain tools and certain methodology, and especially data mining applications applied in cryptographic domain. So we will share, I will share the list of certain tools that are quite useful for your privacy preservation and cryptographic domain related studies. So basically, what is my aim? My aim while teaching my students is to explain various components that are available right now in information security domain. So first of all, my students are highly engaged in information system. They try to create certain software in the form of projects. So these projects which my students used to create are either application software or maybe some system softwares. So basically, this is the organization of any client. This is the client organization where day-to-day data or day-to-day activities are being generated here. So I can say operations are being performed here. And the data which is being generated by these operations will be recorded or will be processed at certain information collecting mechanism, or say I can say data warehouse. And there is one more thing, that is the client itself or the team of client or the management, top level management. So basically, whenever any software or any system, any IT product, which any industry, any organization is using or going to use, will have to look what the data is being generated. So operation, and there is one more component, and that is the information component. So information component is always using data mining techniques or tools for processing the information. So day-to-day operations,
Shaligram sir, you are muted. Please unmute yourself.
and the information that is being generated by IT department will be managed by certain components by providing planning, by providing certain resources, and some controlling instructions. So these three things are useful. So for this data or operational data which is being generated by the operation covers one field, that is information security domain. The second component is development of the software that is being generated by the organization, and operational. All related data, day-to-day operation is there, or it may be any other organization where say it may be banking operations, day-to-day operations are there, and data is generated by these organizations. So one thing, data source which is generating the data. Second thing, the data which is being captured by the organization. So front end portion is there, back end portion is there, and there is certain API that is transferring the data. In small organizations, both the setup is placed at one geographical location, but in big organization, the entire system is kept at cloud. So what is happening? A client comes with certain requirements for managing the organization and for continuity of operations without any interruption and security of entire setup. There is one more thing. First, tool. Second thing, tools. One more thing, that is applications. And third, set of rules. Set of rules. These three things are very essential for any organization. Now see, the basic thing any student or any industry or any organization relates to the passwords, or more generally, it can be termed as a key. And in order to generate the key, the security system says that the key or the password must be alphanumeric in nature. जो भी की आपने ली है वो कैसी होनी चाहिए? अल्फान्यूमेरिक होनी चाहिए. What is the easiest way to create that key? What is the easiest way to create the key? Use personal detail. Use personal details like date of birth, like PIN code, like vehicle number, like your date of enrollment or engagement or marriage, or any other thing that you know easily, or you remember easily, and by using that you can you are trying to secure the system. But in order to make the key strong, की को स्ट्रॉन्ग करने के लिए क्या करते हैं? आप इसका कॉम्बो यूज करते हैं. You create combination of these terms. Say my date of birth is 2706 and my first name is this, and say my PAN card is this. Like this we can create, or I can write another way to develop the password or the key in alphanumeric way. say Introduction to Algorithm by second edition, Corman, Liserson, Rivest, Steen, PHI publication 2009. So this is my another way to create the key. But this type of method is not common. So people always used to use their personal detail, and this personal detail is always available in social media. Now, anybody in the network can get access to the personal information from the social media, and if the personal information is available, then the permutation combination of these can be easily mined. So key mining is the term that can use. So I have used one tool that is available on internet free of cost, and in fact there are several tools that I can use. For example, if I try to share this location or the link from where is the screen visible? Is my screen visible?
Yes, sir. It is visible.
Okay. So yes, the tool is there. So barclay.net, I will share this at the end of the session also. So you can see there are n number of tools. So particularly I have used this a priori algorithm tool. Let me zoom it first so that it can be visualized. So n number of tools are there. You
Sir,
can see.
So your tab screen is visible,
One
but
second.
not your laptop screen.
Okay, 1 second. Is it visible now?
No, sir.
1 second, 1 second. Let me start. I have to give permission first.
Sir, you have the permission to share.
Yes, system preference. Okay, let me open here also. Bargelt, BORGELT. Yes. Is this site is visible to you? Is the site visible?
Yes,
to
sir,
you?
it is visible.
Yes.
Yes.
Okay.
Christian Barger's web
So
page.
in
It
this,
is
yes. Here you can find plenty of data mining tools, and specifically if you go to this software tab, so there is a list, and these tools are developed in multiple programming languages. Like some tools are implemented in C, some are implemented in Python, some are implemented in Java. So I have used this a priori tool. So first, while creating any information security analysis, I have given one problem that create one key. Create one key. Create one key. Key आपको create करनी है. How you will create the key? So there are multiple components in the key. First component may be your date of birth, or it may be your nickname or your friend's name, and the third component maybe say your vehicle number or registration number or any other thing. So this is one parameter P1, this is second parameter P2, and this is the third parameter P3. And all these information are already available, P1, P2, P3 are already available in social media. So what is the probability? What is the probability that one person can guess the key? Because P1 is available, P2 is available, P3 is available. So first of all, a survey has been conducted that whether persons are using these parameter to create the key. पहले एक survey कर लेंगे, and the survey was to ensure that whether people are using these components in their key or not. So yes, we found that certain users are deliberately using nickname or their partner's name or their date of birth or their marriage anniversary date or their vehicle number or their combination P1 only or P1 and P2 only or P1 P3 only or P1 P2 P3 like this. So all permutation combination are using. So the question arises, how to check, how to ensure the strength of this system. Because all the parameters are available in public domain. So the thing is that in every system, in every information system, the key component is user. And even with 100% resources, with 100% resources, you can invest 100% cost, even though the system may not be safe because of this person, because of the user. Is the screen visible to you? Arun sir?
Yes, sir, we are able to see.
Okay, good. So what is my intention? My intention is just to ensure this information security perspective and how we can apply the tool and from where I can get the tool. So I can find out the association rule mining and what are my ingredients. What are my ingredients? Ingredients are all those values which are available in public domain, that is the social media. And by the combination of these public values, one person has created a key. So how the key is secure? So user level, infrastructure level, and network level. At every level, the security aspect has to be dealt with. So in this particular Christian Bartlett site, all the necessary tools are available and they are available at free of cost. And since they are developed in C or Python or Java, so their usage is quite simple. So I will demonstrate some chart that I have conducted by using P1, P2, P3, like this 22 parameters I have used. And using the 22 parameters, we have created how many candidate keys or how many association rules are generated, and can one person generate the 100% accurate key of the user. So by putting this hypothesis and using this a priori tool available on this Christian Bartlett web page, we have found out some interesting features. So let me share these interesting pattern and features, that what were the number of association rules and what were the frequent parameters that were used to generate the key. So let me share the screen first. So the work, is it visible? Is the screen visible to you?
Yes, sir, visible.
Yes, sir.
Okay. So here we can see what is my intention. Frequent pattern we have to mine. So what are the ingredients? Yes. So a priori approach was used. So for this, I have used some parameters. So what is P1, P2, P3? These P1, P2, P3 are your public information, which is available on your Facebook profile, which is available in your Instagram or any other social media accounts. And by using and S1, S2, S3, these are the multiple sessions. And in these sessions, we have taken separate keys. In session 1, we have used a key with the parameter P1, P2, P4, P6. So let me show you first where are these P1, P2, P3. So the parameters were here. For cryptic, we are basically developing the algorithm for, we are trying to mine the frequent pattern that were used by the participants in a social media for creating the key. So here, what is the first parameter? First parameter is let me demonstrate first so that, yes. So D1 is the data, and first data I will share with the server with the key SK1. And how SK1 is created? P1, P3, P4, P6 using this. And how D2, how the second key is created using data set D2, P3 and P5. So in every session, if I am using separate key, using separate parameters, there is one approach where every time I am using the same parameter for creating the key. And the second approach is I am varying the parameters. And if parameter is changed, then obviously the keys constructed will be different. And the constructed key, if constructed keys are different, then we will say that it is the automatic variable key. And in automatic variable key, we have first constructed almost 6 parameters that have been used. So there is one frequent set. If one round of scan is there, and if the key is generated by taking the pair and P1, P2 were used in multiple sessions frequently, Then we have created here frequent set 2, and similarly, this is the frequent set with 4 parameters. 1 second. So let us see what happens. So this is the log of transaction S1 to S25. These are 25 various sessions, and every session was using a different key. How the key is changed? Key को कैसे change किया गया? By varying the parameters. Session 1 was using a key, and the key was constructed using parameter P1 to P6, P1, P2, P4, P6, and P16. And second was created by using the parameter P1, P3, P4, P6. So if we apply a priori algorithm with the first scale by finding out 1 frequent item and 2 frequent items, 3 frequent items like this. So 1 frequent parameter set is this, and similarly we have computed candidate set C2, C3, and so on. And the same has been constructed using this tool, a priori, that was developed in C language and was creating frequent item set with all closed maximal generators and association rule inductions. So it has been found that the number of items or number of candidate set was increased up to say 10,000 or 20,000 frequency, and it is almost hard for a system to predict the actual key. मतलब सीधी सी बात है, मीन्स फाइनली अगर हम इसको कंक्लूड करें तो हम ये कहेंगे कि अगर पैरामीटर्स को बदलते जा रहे हैं हर सेशन में और हर सेशन में पैरामीटर्स चेंज हो रहे हैं तो it becomes hard because the number of associations rule comes in the 1000, or the association rule file is generated in the form of several gigabits. So it is almost hard to predict the key for the next session. So this is the way where we can identify the strength of a crypto system. And if the crypto system is assessing the frequency of parameters or frequency of association rule, then it becomes a hard problem and the entire system will remain the secure. So if person is using keys value or parameters for constructing the key, and the key parameters are available in the social media, then it becomes very difficult for a hacker to use those keys. आप की सोशल मीडिया पर रखी हुई है, सोशल मीडिया पर रखे हुए फील्ड से भी की बना रहे हैं, then also it is very hard because in the next session you are using some other parameters. The frequency of association rule and the file size of the generated candidate set is almost NP hard. So this tool is easily downloaded from the site and you can try and test it because you have already gone through so many tool sets for using and for solving your own purpose. So in information security domain, it is very difficult to find out the pattern because we say that the crypto system is ideally must away from generating patterns. There should not be any pattern, but since all the methods are generated frequently, by computer-based random numbers. So there are chances that the patterns will be generated further. So I hope I am clear to you how the privacy preservation and frequent pattern mining can be applied and which tools we will use for finding out the frequent pattern. And if you have any query, you can write me or you can contact me. I am available on pre-decided time. You can take time from me also. And you can discuss with Ashok Sharma sir and Raghuvanshi sir also. Thank you.
So thank you very much, sir. Let me find out if any queries are there. But that's really wonderful to start with the data science FDP and data science tools and social media analytics, and then role of AI in healthcare and all we have covered in this FDP. And finally, we have ended up with some privacy security, that since we are talking about a lot of data, so we must know that how to secure our data, and what are the different type of keys, like the automatic variable key you just told. That's really a wonderful add up of this FDP would like to say with your keynote on this area. That's great, sir. That's great. So we will keep in touch in future as well for further collaborations. So thank you very much for your valuable time you spared for us. Please stay with us for the valedictory, which is going to start soon within few minutes. So thank you, sir. You can stop sharing your screen. Yes.
Okay.
So let me now welcome. Okay. Yeah. So that's great, sir. So now I welcome the dignitaries on the board on the valedictory function. One peak FTP we had initiated on the Sunday 16th of Jan, and today is the 22nd. So on board we have our chief guest, Professor Pamnesh Abrol, head Department of Computer Science, University of Jammu, who was driving somewhere, but we are very thankful that when I spoke to him to spare some time for us, so he's there in somewhere he's traveling, but he has given us a time for the same. Thank you very much, sir. Very much. Thanks a lot, sir. We have Dr. Kamlesh Kumar Raghuvanshi from Delhi University, Department of Computer Science. Thank you, Kamlesh ji, for being with us on this valedictory. We have Dr. Jatinder Manhas, head Department of Computer Science, Vadava Campus, University of Jammu. We have Dr. Anun Agarwal, the coordinator of this FTP from Delhi University, Ramanujan College. We have Dr. Brijesh as well. And also we have the Dr. Shaligram Prajapat, Associate Professor, Devi Ilha University, Indore. That's great. So I thank you all on this valedictory function, and I extend my warm regards as well to all, because you have paid your valuable time. I would like to give a brief reporting of what exactly we have covered in this one week. This FDP was started on 16 January with inauguration by Rector Sir, and then Professor S.P. Agarwal, Principal TLC from Ramanujan College with his, and then we had a keynote speech from GSW, Director General Manager, Social Analytics and Media, Pawan Patel. In this FDP of 1 week, we have covered almost most of the tool which is being required for data science analysis and data science modeling, covering from RapidMiner, Python programming on Jupyter, Spider, then ClickSense for dashboard creation, and then Veka for data analysis. Then we have covered also some tools for speech recognitions. And in this FDP, I'm very happy to intimate you, bring in your kind notice that very reputed academicians from very reputed institution like from IIT Kanpur, Professor Shalv, Dean Research, and Professor in Statistics has also delivered his talk on our studio. Professor Neeraj Sharma from Thapa University, highest cited researcher in Web of Sciences in 2020 and 2019. He shared his experiences in blockchain. We had the speaker from Central University of Lucknow, Dr. Aditya, Dr. Jimmy from LPU. And in the morning, we had a talk from Dr. Karan Natwaniji, very active researcher in the area of speech recognition in underwater acoustic. That's very emerging area he's working on. So mostly we had approximately 18 sessions in this FTP, and where the role of AI, role of data science in healthcare was explained and even demonstrated by the researchers on various tools. And also we had we had a glimpse of the upcoming areas in the research, that is the explainable AI, because AI is now going beyond diagnosis to remote diagnosis, remote caring. So Dr. Aditya has delivered his talk yesterday on explainable AI and its scope in the era of 2030 and 2045, how the things are going to be changed. So that was really a very nice group of speakers across the India there was, and approximately 170 participants from India, and some participants from some other countries like Russia. They also joined on YouTube live streaming. We had also some speakers from University of Copenhagen and some from Denmark, but unfortunately, because of the time issues, we couldn't allow them to share their experiences, because timing is the issue. No doubt the COVID has finished the distance issue, but timing is still the issue. So that's why we couldn't get those two speakers on board in this FTP. But ultimately, we have come out with a very fruitful outcome. A lot of research collaborations we are expecting, and more teaching and learning, strengthening the teaching and learning process in higher education we are expecting from this FTP. And we are very much thankful to our rector, Vadava campus, for initiating this MOU with the support from the head department of Computer Science, University of Jammu, Dr. Pavnesh Abrolji, the head department, Jatinder Manhas. And this FTP is really could not have been possible if we couldn't get a support from our faculty co-colleagues from Vadava campus, Professor Dr. Mr. Neeraj, Mr. Ajay, Dr. Abid, and research scholar, Ms. Shalu Kotwal, Diksha Sambyal, Rachit. And from Delhi University, we had a very good cooperation and coordination from Dr. Brijesh, Dr. Kamlesh, Dr. Arun, and his team from there. And ultimately, the support from Professor S.P. Agarwal from Principal Ramanujan College. So I once again, on behalf of Department of Computer Science, Vadava campus, and as well as Department of Computer Science, University of Jammu, extend my thanks to Teaching Learning Center of Ramanujan College for extending their cooperation towards the smooth conduct and organizing this FTP in a very wonderful way, because all the technical support from their end. And we do hope that we will keep on such type of collaboration, academic collaboration in future as well. So thank you very much. Thank you very much to you all for your support. Now I request Dr. Jatinder Manhas, Head Department of Computer Science, Vadava campus, to put some few words about this FTP, because he was a part of this as a convener as well, and he has gone through all the sessions as well. So kindly, sir, please speak some few words for the same. Thank you, sir.
Thank you, Dr. Shok. Good afternoon to all. Esteemed chief guest and my teacher, Professor Pavnesh Abrol, Head of the Department of Computer Science and IT, University of Jammu, Principal Ramanujan College, Delhi, Dr. Arun and Dr. Ashok, who is the course coordinator for the entire program, dear participants, faculty, staff of the Bhadrava campus, and the staff and faculty from the Ramanujan College, Delhi. First of all, I congratulate that my campus and Ramanujan College for the successful completion of the course, and the lot of prominent speakers from the IITs, NITs, Central University of various central universities. They took lecture for the entire 5 days, 6 days, and enlightened the students and the participants about a lot of latest concepts in the research in the field of computer science. And they trained the faculty members and the participants regarding the upcoming technologies and tools going to be used for the future research. So let me apprise all that before going for this FDP, the Bhadrava campus has entered into a MOU to conduct such kind of collaborations, FDP, in collaboration with the Ramanujan College in near future too. That is a welcome step for our campus, and Dr. Ashok was instrumental in doing such kind of MOU with the Ramanujam College, and near future also we will keep organizing such kind of faculty development program for the participants. So this is a great achievement for all of us, that even the Dr. Ashok has also prized that almost more than 150 participants has participated in this course. That is not only from India, that from abroad too. So this is a good step for the University of Jammu, and for even for the Ramanujan College, that people from abroad also getting joined and getting a lot of knowledge from this particular initiative. So once again, I extend my thanks to all the speakers and who spared their valuable time and have enlightened the participants on latest trends and tools in data science. And I once again congratulate my faculty member, newly recruited faculty member, Dr. Ashok, who has a lot of experience in conducting such kind of program. And I also encourage other staff members, Dr. Neeraj, Mr. Ajay, and Dr. Abid, to keep organizing such kind of FDP and other research related programs. And I also put my sincere thanks to scholars also, who along with Dr. Shok has done a lot of hard work in organizing such kind of events. And once again, in the end, I congratulate my campus, and on behalf of my rector, since he's not here, he has to join some important meeting there. So on behalf of our rector sir, I once again put my sincere thanks to all the participants, the speakers, and the chief guest for today's function, Professor Pavnesh Parol, and all the staff and faculty members from the Ramanujam College. Thank you, sir. Thank you very much.
Thank you, sir. Thank you for your nice words and nice appreciations for all of us. Thank you, sir. I have Dr. Kamlesh Raghuvanshi from Delhi University. He's also there. He's my ex-colleague, I would like to say. He's my one of his friend. Dr. Kamlesh, please go ahead and share your valuable words with us.
Thank you, Dr. Ashok, and good afternoon to all of you. I would like to thanks again the organizing team from the both Jammu University as well as Ramanujan College. As you know, Dr. Ashok, actually I was also the part of this organizing committee, but when I talk with the Dr. Ashok regarding speakers and topic, because my research area is, I can say, in the software engineering, and I would like to understand about the emerging technologies like blockchain and this data science and new tools and technologies. And around in last 2 years, I was the part of organizing team. So every time I didn't get the time to understand and learn. But in today, I would like to inform all of you, I'm joined this FTP as a participant, and really in each day I learned a lot of new things. That's true. In this short time, we can't go in depth now, but at least I got the how to start in the blockchain and chatbot. This was, click science. It's really, it is not for only the research, it is for the industry also required, because everybody knows data is very crucial, and how we'll manage this data. So we have to learn a lot of technologies and everything. So from the Ramanujan College, Dr. Arun, my principal sir, Birjesh, and various non-teaching staff is also involved in this, because the fees, their certification is, even I would like to share here, we are generating the certificates on blockchain itself. And from the TLC using the software we have developed itself. So really, since last 8 years, I know how energetic Dr. Ashok, we both did the research in the same years. And I will also thanks to Dr. SP Prajapal sir from the DAV, Panvesh sir as our chief guest. So today I joined as a participant side. Generally, we used to have a participant, so it's really nice. And like me, I enjoy and learned lots of things. I am sure each participant, 175, it's around 175. So if really someone devoted time, definitely he will get benefited. And not only me, my student will also get benefited, because I am also taking the class same time. So I used to recall myself, and that time I discussed with my students about the chatbot. So Dr. I know I think Karthikeyan given that time. So I was thinking it's too much tough. But when I started learning myself, so I'm able to successfully just generating. So it is just a matter of the data. So thanks again, all of you, and I'm sure we will meet very soon once the environment, uh, allow. Then definitely will we meet and maybe arrange the uh, physical mode in the Jammu. I promise with the Dr. Ashok and everyone. So thank you. And for this, in FDP also would like to inform. Since last 1.5 year we were planning. Dr. Ashok were keep in touch, but due to various reason or whatever, but finally this took, and this is the last day. So thanks for all organizing team and as well as the support team from the back side. Thank you.
Thank you, sir. Thank you for your such a nice word and appreciation for all of us. And even as a guest and as a participant, you shared your valuable experiences that chatbot development you have started and you are doing it well. So this is a wonderful outcome. At the end, we can say that our participant, our as faculty, our researchers are really doing good. They have learned a lot here. So now I request our chief guest, Professor Pavnesh Abrol, Head Department of Computer Science, University of Jammu, to share his valuable thoughts and to all of us and to motivate us for such type of event in future, so that we keep on doing all these events under his guidance, under his support and cooperation, sir. Please, sir, go ahead, sir.
Thank you, Dr. Ashok. Thank you very much, and a warm afternoon to all present here. I think Professor Rahul Gupta, Rector of Bhadrava campus, he could not join. Professor Shilaigram Prajapat, Dr. Kamlesh Raghuvanshi, Dr. Arun Agarwal, convener, Dr. Jitendra Manhas, co-convener and head of department, Bhadrava campus, Department of Computer Science, Bhadrava campus. Faculty members, Dr. Abid, Dr. Ashok, Mr. Neeraj, Ajay Lakhnotra, the principal, Ramanujam College, members of faculty from Delhi University, organizing team from Ramanujam College, all the participants who are participating in this wonderful FDP. A very warm welcome and a very good afternoon to all of you. In fact, it's a wonderful to know that Bhadrava campus, University of Jammu, has organized and completed 1 day, that is 7 days, FDP on data analytics and modeling tools for research in collaboration with Teaching Learning Center of Ramanujam College, University of Delhi. This program, as I know now, that it is under the aegis of Pandit Madan Mohan Malviya National Mission on Teacher and Teaching, which aims to infuse innovation in pedagogy, leading better learning and research outcomes. So these FTPs are certainly indeed very important for getting the teachers, all the faculty members abreast with the latest technologies in research and teaching. So as mentioned by Dr. Ashok, around 18 sessions took place, and then there were around 170 participants, and some of them from abroad joining on the video that is live streaming. So it's very good to know that in spite of all these restrictions we have, that such an FTP has been arranged with wide participation and with the resource persons from across the one of the best institutes with a lot of experience. And I am sure that this must have been a wonderful session on wonderful FTP for all the participants. And there are certain participation from the participants from Russia, as mentioned. This is definitely a great initiative by the University of Jammu Department and Bhadrava campus and Delhi University towards academics and research collaboration. I appreciate Dr. Jitendra Manhas, the head Department of Computer Science, Bhadrava campus, for such initiatives. I know that he has been very active all through, and he takes on and sees to it that some good activities are always being conducted. And this is one of the, I think, wonderful activities that have been conducted in the academics and research in collaboration with the Ramanujan College and Delhi University. So, and I also congratulate the faculty members, Dr. Abed, Mr. Neeraj, Mr. Ajay, the research scholars and other staff and faculty members of the Bhadrava campus. I think I must also appreciate the leadership of Professor Rahul Gupta, who is the rector of Bhadrava campus. Ever since he has taken over as rector of the campus, he has been very keen in conducting and doing some kind of activities which are in the interest of the teachers, researchers, and the scholars, students of the campus, as well as the entire fraternity. So it's really a lot of congratulations to Professor Rahul also from my side. As the nodal department, as the head of the nodal department, we have around 4 offsite campuses along with the government degree college, which is associated with us. And let me tell you all present here that Bhadrava campus has a very good faculty. One of the offsite campuses have now got a strength of very good faculty and has been doing very well in terms of also the recently conducted admissions and also in terms of the academics, in terms of conducting the examination, the research. They have some good number of research scholars with their faculty members. And recently we have also updated our curricula in light of all these technological advances and to inculcate all those. We had the recently curriculum reform workshop of RUSA 2, and we modified our syllabi and to include the latest, including Python, big data, machine learning, fuzzy logic, cloud computing, cyber for security, with Java and VHDL, high definition languages like introduction to VHDLs. And this is very, therefore becomes very important that such FDPs are being organized so that our teachers also remain abreast with the latest happenings and developments in the fields of technology. I very well agree with Dr. Kamlesh Raghuvanshi that we all are learners. So I also enjoyed the lecture. I joined a few minutes earlier and I was listening to the last parts of the lecture by Professor Shalaigram Prajapat. Wonderful lecture. It was very research oriented and I only thought that I would have joined earlier to understand and know the latest what is going on in this field. I really hope that such programs are being organized time and again, and we and our teachers and our staffs and our scholars get the opportunity to listen to the leading academicians and researchers across the country as well as abroad, and this will be wonderful and very valuable. Such events are very valuable for all of us. I extend thanks to all the speakers from my behalf. I extend thanks to all the speakers who have given and spared their valuable time and have interacted with the participants on the latest trends and tools in data science. I put on records the appreciation for Dr. Ashok Sharma, who is the coordinator and who's coordinating the program from University of Jammu, and Dr. Arun Agrawal and Dr. Kamlesh Raghuvanshi from Delhi University for organizing and managing the event in a wonderful way, in a very professional way. My best wishes to all the participants, and I again agree with my earlier speaker who was saying that, of course, physically we could not meet, something which we look forward to, having a cup of tea with all of those who are with us together in this program, we certainly look forward to. But I also agree with Dr. Ashok that, of course, this virtual connection has reduced the physical space issues. But I hope with the technology changing and with the technology moving ahead, another important aspect of time and space, two dimensions of the physics, very important dimensions, will also be somehow met, and we may have different times on different platforms, possibly like streaming or some other platforms as we proceed in time. So I really wish all of you to have wonderful sessions which you have. I really hope that this must have been very productive. And my good wishes to all the participants and all the faculty members of the Department of Computer Science, Bhadrava campus. Thank you very much.
Thank you. Thank you very much, sir, for your kind words and your appreciation and your motivation and your support to all of us from time to time, and your dynamic leadership in the offsite campuses. We are doing very good, and really this is great. And 5-year integrated course which is initiated by Dr. Manhas under the guidance, support, and with your leadership we have also initiated the same, and we hope that will be on the board soon. So this is all your efforts which you put in academics. That's great, sir. So now I request Dr. Arun Agarwal to kindly present a formally vote of thanks to all dignitaries. Please, Dr. Arun.
Thank you. So a very good afternoon to all everyone present here. I, Dr. Arun Agarwal, convener of this 1-week-long FDP, on behalf of the entire organizing team, extends a hearty vote of thanks to our respected principal, sir, Professor S.P. Agarwal, Professor Rahul Gupta, sir, Rector Bhadwa Campus, University of Jammu, and Professor Pavnesh Abrol, sir, Head Department of CSNIT, University of Jammu. And our keynote speaker, Dr. Shaligram Prajapat, who spared time from his busiest schedule for this last session of 1-week-long FDP. I would like to thank all the resource persons for sharing their valuable insights, which will definitely benefit all the stakeholders of this FDP, who will definitely benefit all the participants as well as all of us. I would like to thank all my team members from Ramanujan College, Dr. Nikhil Rajput, Dr. Ashish Shukla, Dr. Brijesh Kumar, Mr. Vipin Rathi, and Mr. Subodh Kumar. And my team members from University of Jammu, Dr. Ashok Sharma, Ms. Shalu Kotwal, Rachit Gupta, Ms. Diksha Sambyal from University of Jammu, for their cooperation in this online FDP. With my sincere appreciation to Dr. Ashok Sharma, who has been the strength of this FDP. I would also like to thank Mr. Ravi Bisht and all the backend team from Ramanujan College and from University of Jammu, who provided their utmost support in managing this FDP and to make this FDP a successful one. I'm sure that this FDP had definitely benefited all our participants, and they are able to understand various research and modeling tools. Thank you all once again for making this FDP successful. Thank you. Over to you, Ashok sir.
So thank you, Arun sir. And once again, I extend my thanks to all of the dignitaries on the board, and we are sure that in future we may also collaborate and going to conduct such type of events for our research scholars, for our faculty, and for ourselves as well. So hope to do the things again in future, and let's begin for another FDP. Soon we will be interacting with you, sir, and we will be organizing the same in our campus in the University of Jammu. So with these words, thanks once again to all, Dr. Pavnesh Abrolji, our chief guest, Dr. Jatinder Manhas, Dr. Shaligram Prajapat from Devi Lehava University Indore, Dr. Arun, Dr. Raghuvanshi, and Ms. Chalu. So thank you once again, and we hope we shall meet again in new soon. Thank you very much. So we
Thank you.